Hi everyone, my name is Yuri. I am a CEO and co-founder at Scope. And Scope is a project management software which focused on communication, and it's fully based on Clojure, backend and frontend side. And I'm happy to be here to share with the community how we built incredible UI on ClojureScript. So, within this presentation, I would like to share our experience, how we built a JavaScript application, a ClojureScript application on all aspects, provide details, what we use, why we decided to use these scenes or another scenes, and convince you that it's fully safe and efficient to build any size of front-end application on ClojureScript. Sorry, I have something strange. Sorry. And first of all, I would like to say that I have a pretty big experience in JavaScript world. Before I worked with Node.js and JavaScript and React, and I know how to cook efficient front-end application on JavaScript. And when we started to work on Scope, I was fully confident that we will use Clojure on backend side. We know how to cook efficient and reliable backend on Clojure, and we really want to use ClojureScript on front-end side, the same language on backend and front-end side. But I saw some challenges. And first of all, it's runtime overhead. We expected to have a lot of UI in our application. So it will be a lot of rich UI with a lot of models, a lot of popovers, and I worried about efficiency and how we can, about performance and how we can render it efficiently. So also problems that existing library were behind of the latest React version, and the most of existing library were created when React used JavaScript classes and lifecycle methods, which currently deprecated. So, and I was worried that in the long run, it will be not safe to easily migrate to new major version of React, but it was really important for us because the React team is doing a lot of work on performance optimization and all this stuff. So, and also I would like to say that based on my experience, it's pretty difficult to find ClojureScript developers who can cook front-end very well and know ClojureScript libraries with their own concepts. So, and our solution was pretty simple. We just decided to rely on React API and its ecosystem. So, and everything what we need is just to use tiny wrappers and to do a lot of things as much as we can in compile time to reduce overhead. So to do it in macro. And I would like to say that we already built incredible UI, and so everything built on ClojureScript, and just take a look on this 30 seconds video what we already have and how it works. Cool. Sorry. Next slide. Now I would like to share step by step what we used and explain it in detail. First of all, I would like to talk about such important things like design system and UI kit. It's important not only for ClojureScript project, but it's also important for any front-end project. If you are worried about your velocity, about efficiency, how you build your application, it would be really awesome to build solid design system, which your components, standard components, which with colors, standard colors, typography, and shadows with your icons, and you need to build all your component in isolated environment. So, and I suggest to use such approach not only for UI kit, but for building your application too. So it's much easier when you can build some part of your UI and create this UI with state and work with it, because you can test it. You have all state here, and you don't need to find this state in your application. So at the beginning, we started to we are using Figma, and with Figma API, Figma provides incredible API. We just created a few simple scripts on Clojure and fetch via HTTP all colors, typography, shadows. And I would like to say that it saved a lot of our time. So now we just need to run one script or put this script into our CI, and we fetch all colors, shadows, typography, SVG, and generate some files. Just ClojureScript files with variables, and that's all. And awesome thing that we forgot to sync these scenes. We just run file and can see difference in git diff. It works great. So on the screen you can see already generated 3 files, and one file with typography. We are using dev CSS here, and I will explain what does it mean in next slides. So the same with icons. We decided to use SVG everywhere. We don't use Phantasm or something like this. We use only SVG, and you can fetch all SVG from your Figma, and you will automate this process completely. To do something in your script, for example, optimize SVG via SVGO, and to do any other things. So how you can use SVG in your application? I would like to say that SVG is a valid React component, and everything what you need is just to read SVG file, parse its content, camel case all properties. In our case, because we are using monochromatic icons, you need to replace, for example, in our case, white color to current color, and to be able to use any colors for these icons in your application, and convert to create element, to React component via create element. And in general, that's all. You can do all this stuff in compile time, and it works amazing. So just take a look on the screen. So you can see here how you can do it. So I already explained all these steps, and you can see the macro emd, and in this macro we just read SVG file and generate a React component. And to use it, so we created one more macro like dev-svgc, and just to be able to use it simpler, and use it like dev-svgc bookmark SVG, bell SVG, or team SVG. And now it's a fully it's a React component, and you can use it as any other React components. So we use this approach more than 1 year. It works great without any problem. We already open source it, and if you want, you can use it. One important thing here, that if you decided to, for example, import bell SVG a few times, you will have a content of this bell SVG in your source code. So you will duplicate content of this SVG in your source code. To avoid it, we have global atom, and when we import SVG first time, we add a component to this global item, and next time we just use this component from global item instead of duplicated in source code. So you can use SVG rec if you want. It's open source already. Also, about isolated environment. I think it's really important to develop your components in isolated environments. You can test it great and easier. And we started to use dev card at the beginning, but really quickly we migrated to Storybook because we have a lot of components in our UI kit, and we need to have a category, subcategory. Also, we are working with themes. We need to have documentation, and that's why we decided to use Storybook. Storybook is a really popular library in JavaScript world, and it's super easy to use in your ClojureScript project. So, I would like to say that everything that you need to use Shadow CLJS, and by the way, the Shadow CLJS incredible build tool. We are using it in all our front-end project. And to run Storybook in your ClojureScript project, you just need to define build with target npm module and run Storybook with Webpack 5 builder. In general, that's all. So you can define another options, but in general, so it's everything that you need to run Storybook in ClojureScript project. Also, as you can see, for example, here we are using some add-ons like docs, control, themes, which pretty useful for us. And so you can decide what add-ons you need to use. So we have Storybook has a lot of add-ons. And as a result, we created a few macro, devStoryDoc and devStory, just as a sugar to use to create stories easily. And in this case, you can see that we have component stories page forms token with two themes. So this component support light and dark theme, and also we have spec for this component. So I would like to say that we have spec for each of our component to explain properties and to do some additional things like generate documentation or validate. So I will show how it works soon. And so you can see two stories, default and with icon, and you can create your own story, pretty easily defined properties for your component in this story and work with it very well. So we didn't open source these macros yet, just because it's pretty easy to create them, but our code looks not pretty good right now. We need to polish it and add some documentation, but maybe we will open gist files or something like this. So they're pretty useful. And it looks like this. So you can organize your components in UI kit, play with it in your controls panel, and your developer experience very well. You have fast refresh, and you can develop your components in isolated environment and create your own state for each of component. That's all. The last thing which I wanted to say about design systems, that we are using it just a dependency. So we develop it independently, use it just a dependency without any styles overrides, and so it works great. Next, let's talk about building React component. So we decided to use Helix. It's a very good library which provides, because we decided to be really close to React API and Helix. It's just a library which provides direct methods to use a React API. So pretty easy to use, and you can see you use the same hooks like use callback, use state, or something like this, and you don't need to know any other additional concepts. So you don't use hiccup, you just use Clojure and React methods. Also, we are using Emotion CLJS. This is our own library. We open sourced it more than 1 year ago, and I would like to have that we use the same approach as Helix. So it's just a few simple macro on top of Emotion. Emotion.js. Emotion.js is a pretty popular library in JavaScript world. It's a CSS and JS library designed for high-performance style composition. And Emotion.js, it's a set of macro to work better with this library in ClojureScript. So also we are using Mali for spec of our components, and I would like to say that we started with Clojure spec at the beginning, but we migrated to Mali just because it's really easy to explain your spec as a data. You can combine this data, you can remove this data from your specs from production build and generate, for example, documentation based on this data. So Mali works great for us. And for test, we are using Karma as a test runner and React testing library for rendering components in our test. Why we decided not to use Reagent as a library for building React component? We love Reagent, we used it before, but when we started to work on this project, Reagent was behind of the latest React version, and we were not confident that in a few years, for example, React team will deliver a new major version, and we will be able to upgrade easily. That's why we decided to use just simple interop with React. And also we wanted to avoid hiccup, so just to reduce runtime overhead, and I think that you can explain React component in Clojure syntax very well too. Also, why it's so important for us to use latest React API? So I would like to say that React provides not only so it's not only library for rendering React components. Already React provides a lot of things, such things like React context, which you can use as a state manager, React suspense for data fetching, for example. So currently you can use such things like SWR as a hook, but in next version you will be able to use native React API for data fetching, and it works efficient. So I would like to say that React team works a lot on to do rendering efficiently, and they provide such things like concurrent rendering, automatic batching. They provide new tool to give developers to create their front-end efficiently, such things like start transition, use transition, suspend again. And also, which is really important for us, JavaScript developer just need to know Clojure syntax, and they will be able to write their front-end on ClojureScript, because they will recognize that it's understandable for them. They can see all React hooks, and so only Clojure syntax. Yeah. So how it looks? Sorry. You can see this component, toggle button component. So, and in this example, so you can see that we use React methods and Helix methods. It's just a wrapper for React API easily. So, for example, React forward ref or Helix memo, which is the same as a React memo. You can see another hooks here, like use context, use state, use callback, or even new modern new hook like use ID. It's easy to use, and it's just React with Clojure syntax. And also, we decided to create one more macro on top of Helix macro, defnc, and within this macro we enabled such feature like fast refresh, check invalid hooks usage, and we check spec of these components, because you can see we have spec number 3 for these components. We can check spec of these components and validate it. So also you can see a styled component button. We defined all our styles in the separate file, so in styled CLJS file, and it looks like this. So it's just a styled component. We are using emotion, which we already open source, and you can use it. And so you can see two styled components here, button and chevron icon. And you can define any styles. It looks really good. You can define conditions for styles, like for example button size 500, and you apply these styles only when your property size will equal 500. You can use all your variables which you already imported from Figma, and you don't need to worry about it. And for example, you can see that we use typography text 540, we use some colors in our themes files, and easy to create really difficult styles and combine them. So it works really efficient for us. I would like to say that we have a lot of UI and work with styles in this way, really efficient and also performance great. And Mali for as a spec for your components. So for example, in this example, you can see that that we have required and optional properties like size, collapsed, children. And based on this spec, we can render, for example, browser console warnings. You can see it. And also we can throw exceptions in our test when something wrong. And Mali helped us to generate really cool explanation what doesn't work. Also, based only on Mali specification, we are able to generate documentation in our storybook. So on this screen, you can see that we generated documentation for popover component, and so it's just based on Mali spec and nothing else. So you can see description, you can see some controls, you can play with this component using these controls, and it works very well. And small macro, just 50 lines or something like this, work very good. So, and we already built around 130 components in our UI kit and more than 600 components in our application. We are feeling really good developer experience, fast refresh, and performance, very good. Let's talk a little bit about building application. So we have really solid design system. We know how to build our components, and now we need to build application and all their aspects. So we are using Shadowcell.js as a build tool, and we also use Rated, I hope I say it correctly, as our router, and also we use React context for application state manager, and such hook like SWR hook, plus React suspense for data fetching. So first of all, you need to define your Shadowcell.js config. So it's a pretty common config. You can read documentation on Shadowcell.js site. Nothing really important here, just you need to define target browser, some your options, and it works great. So, routing. Awesome, because we can define our roads as a data. Also, I would like to share that we use the same roads for our backend and frontend. We can share this code. And we just defined some routes here. It's easy to explain any type of routes via map. And that's all. Then we register these routes via start methods and and register callback when something changed, when the HTML5 history or hash change event happened. also, we dispatch some event. For example, you can see that we dispatch set active route event and update application state. We are using Atomics library here. It's a small library which use based on React context, and now it's based on React context. I will talk a little bit about it on next slide, I think. So, and that's all. So based on this application state, you can render your layout or your page and anything else. Yeah. One more question, why we decided not to use reframe. And the same because we decided to rely on React API, and we think that React context. So you can do this. You can do efficient application state with React context. So, and you just need to organize it and use. I also would like to say that instead of one global state, we decided to have like a separate global state for each our entity. We also use normalized application state and store our entities separately in global context. So, and we decided not to use reframe because we have everything with React context, and also a small thing that reframe has reagent as a dependency, but we don't use dependency reagent, and that's why we decided not to use. So we don't need it. But reframe incredible, and we use the same principle, the same concept which reframe provides to build our internal library Atomic. So based on React context. So I would like to say that first version of React of Atomics was built on Clojure atoms, but it works much efficiently, much better on React context, and currently we are migrating to React context. So we have the same concept, like define and register event to update this context, register effects for HTTP request, local storage updates, working with local storage or session storage, define selectors to have an access to your data in your context. Yep. I would like to say that we definitely want to deliver Atomics to open source Atomics. We will do it, I hope, this year, just to need to migrate our application fully to React context and to be sure that it works great. And after this, we definitely work on documentation and open source it. And a little bit about lazy loading and code splitting. So I would like to say, when you care about your application and build huge application, so it's really important to think about your bundle size and how many code you need to load at the first time. So, and I wanted to say that it's so you have everything what you need to lazy load your component or split your bundle to smaller chunks. Everything what you need is just to use shadow lazy and React lazy, and that's all. For example, in this example, you can see that we created macro lazy component, and then when you need to load some component by request, you can just wrap your component like project create model into lazy component macro, and that's all. Of course, you need to worry about what you will show on your UI when this component is loading. You can use React Suspense to show some loaders, and yeah, it works great. To use code splitting, Shadow CLJS provides everything what you need. You just defined modules in your config. And for example, in this example, we define signing up, layout, and project settings model with some entries and some dependencies. So, and this now we have 3 chunks, like 4 chunks: UI kit, core, signing up, layout, and project settings, and Shadow.js will care about the rest of things when you need to load it and use it. Yeah. So, and as a result, I would like to say that benefits for us incredible. So we use the same language on backend and frontend side. So we share a lot of code. We use some function on backend and frontend side. We share specs, we share roads and other things. We are using NPM libraries for drag and drop, for example, or rich text editing because of incredible JavaScript interop in ClojureScript. We have very good, solid developer experience and excellent performance. So currently we built a lot of UI and our performance great. We're happy to hear it. We're happy to see it. We do a lot of, we care about performance of UI. We use virtualization to render only visible scenes. We don't render, for example, some models which are not visible right now or some popovers. And so everything works great. Code maintainable, scalable, and is Clojure syntax, and really efficient to write such code. That's all. Thank you very much.